change this to 14, and then I do an LVS, there's the size, 14 in one and 20 in the other, and if you click on them, it'll tell you where the errors are. Okay, so let's do a Control Z. All right, we ready? We're almost done. We're ready to put things together. So should we make an icon or not? Nah, let's not. You know how to do that already. But let's go make a, we'll start making a ring oscillator. I'll just call this Control. You don't know what that is. It's just some inverters put together. Control N, ring oscillator. And then let's drop in our inverter layout bit and show that. Or you know what? Let's not show it because I see my ports here and I can change the size, but if I come in and I put another inverter on there, I can then connect the ports up and I automatically have connected ground. And so when you're doing your design, it routes the power and ground really easy. So it comes over here and I've got my VDD, and then my out of this one, say, goes here, and I can come back around. And let's see what happens if I do this. That's not going to work. Yeah, you do up the metal too and do it, but just to see here, whoops, then I can shift this around. Yeah, you get the idea. And let's zoom in here and then use the arrows. And then we can do a little showing. And then let's see, I bet I've got an LVS problem, or DRC problem. One error. What do you think the error is? Well spacing right here. Let's find out. Hit shift greater than. Oh, unnecessary pin. Delete that. F5. Okay. So let's scoot it even closer. That's why it's nice to put it on there. But now I've got a layout. Let's see if I DRC. No errors found. Now, it should have flagged that there was an error when I had those wells really close together. So now I'm going to go back and change something. But are there any questions before I do that? Does everybody see how I've routed my VDD? And if I were to just show the N well, I'd have an N well with all my PMOS here and a P well or P substrate with all my NMOS down here. In a real standard cell frame, you might put your inputs and outputs on metal 2 so that you can route your metal 2 up and down and your metal 1 left to right. So that way it makes routing really easy when you're connecting things together. Okay, so what is the comment? I think I put it in one of the Google emails about the well spacings. Maybe I didn't, and I'm just looking at something else and some other things, so I'll just tell you. You go to Preferences, Tools, Well Check. Check DRC spacing rules for wells. If I have this checked and you don't, you do your DRCs and it works great. Now you come over here and it says, hey, I'm going to do my design rules. Okay, I guess I'm fine there. Let's go move this away, see if we can force an error. Oops, let's just move it away a little. F5. Let's see what the spacing is. Control G. Oh, maybe it's smart enough to see the wells are at the same potential. I don't know. Anyway, make sure you have that checked. Let me just double check. Well check, check DRC, check, must connect ground, must connect. Okay, it must be smart enough to know that if the well's connected to ground or VDD, then they can be right next to each other or overlapping. Okay, any questions on this? Are we learning? Does it seem like that you know better idea now how to lay things out so that down the road it's easier? When you snap all these cells together, it's not like you're throwing a bunch of unorganized city roads together where you can't get anywhere quick. Okay, so let's go back. Question? No? All right, let's go back now and talk about source and drain depletion capacitances and where to look those up and what those are. Okay. So I know if I close this, I'm going to, someone's going to ask a question, so I won't.